Hello everyone, welcome to Robot Learning channel. First of all, please subscribe my channel and like this video, and you can see other video in my YouTube channel. In this video, we want to talk about to create a Lidar sensor using a ultrasonic sensor for SLAM, and it can be used for navigation also. We use Python programming, robot operating system, and Arduino Mega. As you can see, I create a bracket for ultrasonic lidar that it can carry the sonar sensor and a bracket for the servo motor. This is the wiring of the lidar sonar. The sonar and servo are connected to Arduino. Trigger and echo are connected to pin 5 and 4. The Arduino pulse is the blue wire is connected to pin 9. I use a power bank as the external as the extra power source for the servo, because Arduino couldn't provide enough power for the servo motor. So then the Arduino is connected through Wi-Fi to the laptop. This is the circuit of the sonar lidar sensor. In the FreeSync, I use the FreeSync software. We have 4 pins in our sonar. One is trigger, echo, ground, and a VCC, which is the 5-volt voltage. So the 5-volt voltage and the GNDs are connected to our Arduino pins, GND and 5-volt. The trigger, the blue line is connected to pin number 4, and echo is connected to pin number 5. In our servo, we have 3 wires. One is input voltage, another one is GND, the ground, and for the pulse we use pin number 9. Here is the codes for in the Arduino IDE to program over Arduino. Is the combination of sonar and the servo. You can see the libraries that we need. We call the servo library, and it's the message for the publishing the value to the servo, and this is for the sonar. And we use ros.h, the library for the ROS in Arduino. The trigger pin is defined here, 4 and 5. We define a publisher, the topic called sonar, and we call the ROS for this programming. Here we define the function for the servo, which is connected to pin number 9, and we advertise the public sonar for which is here. Okay, we advertise the public sonar, which is the sonar topic. We define the pin mode, out and in for the trigger and echo, and we convert the distance, the pulses we receive, to the distance for the sonar. Okay, in the tools we select the board, which is Arduino Mega. Over port, and we select the port, which is this one. Then you can see the change in here. Then let me run another program. You can see the Arduino in here. When I upload the code, we can see that one is already uploaded. So the upload is done. Okay, in order to communicate to road serial, I just create a Python the ROS package to communicate to calling the node, road serial node, and we define the pins here, and we define the baud rate in here. So we open a terminal, we source to the our catkin, which is save this launch file. Setup bash. I run this launch file. Connected to the Arduino, then through the ROS topic list, I can see the sonar and servo, which is defined in the our programming in the Arduino IDE. So for the testing, ROS equal sonar, we can see the distance. I put my hand there, 8 centimeter, and through the wall it is 14 centimeter. If I change the distance, you can see the measurement will be different. Okay, and our topic list for our sonar, I can say ROS bigger, ROS topic pop, then servo data. We can see the movement. Okay, we give another degree for the test. We can see in here that our servo has been moved. Okay, in order to use to publish the sonar data as a point cloud, as a laser scan, we use this topic of the Arduino. You can see the description in here in ROS documents. Okay, so in our topic we will have the angle mean, angle max, increment, time increment, which is the flow 32, and the ranges and the maximum and minimum range. So I created a program in the Python 3. This is the libraries that we needed for that we need for this programming. So I published the topic as a sonar underscore lidar, which is a laser scan under the this library sensor underscore messages. So in the callback I call the sonar value, okay, and here is we subscribe sonar value, which is the float 64 in this function, and we initialize the node as a laser. It means this program is defined as a sonar node, as a laser. Sorry. So after reading this, the value of the sonar through this function, we define another function that is upload the laser data in a new topic called sonar underscore laser, while over servo rotate from 0 to 180 degree. So we define a function called this list, the a, and we times it to 180 as a default will be 0 180 times, and here we fill each element with the w1, which is from the sonar. Okay, if we check in the Python, so we use this trick. For example, I define a as a 0, then I times it to 180, so I will have a array 0 in that is the shape is 180 times. Okay, so through this one of each time that through this programming, from each angle of the servo movement, we publish one element for v1, which is our list, okay, list of the data, and we publish the laser range equal to b. Then later we publish the laser as a topic under this this row's topic. Okay, let's go. Let's run our programming. I think we already have our topics. Okay, I go over I save it, open a terminal. This is the name of TF. So if we see, you can see in here each time okay. So for better vision, I open RVs. Type sonar in here, then through by topic, call over function. You can see the visualize our data in here. Also through ROS topic list, we can see that our sonar lidar is described here. ROS topic echo sonar see the value is changed whenever we also can check the RQT graph, that we check graph of our topics. We can see the sonar is connected through laser, which is the our node. This is this Python programming connected through connected to sonar lidar, and is this connected to the servo and serial node from the ROS launch. In order to create a SLAM, we use a Hector SLAM package. You can download it from the Github. After downloading, we can go to Hector SLAM mapping. In the launch file, I created the this launch file. In the launch file, we make our sonar laser as a second topic, and we define the sonar link from the statics transformation publisher, this node. We connect the sonar to the base link, which is defined as a bottom and base frames of the Hector SLAM. Then in another launch file of the Hector SLAM, here Hector SLAM underscore launch, then I created the sonar launch file and call the sonar laser launch file in the sonar.launch file. Okay, so we go run our programming one more time, so we can see the movement in here, and then I run the this launch file, sonar launch file. So we can see the demo of the map. This is only the demo, although with the more adjustment in the setting, we can have a better map. Although we have to consider that the speed of this movement of the servo is not fast, so the range of data transferring and reaction to the environment is not fast and accurate. For example, we can replace this with the servo motor with the stepper motor to have the faster movement, so we can have the faster transformation of the data, or we can use more accurate servo to create the range data. Thank you for watching this video. Please subscribe my channel and like this video.